In this video, I'm going to go over examples from the Law of Cosines, which is section 6.6. Recall that the Law of Cosines applies in any triangles ABC with side length ABC facing angles A, B, and C respectively. So A squared is B squared plus C squared minus 2BC cosine A. B squared is A squared plus C squared minus 2AC cosine B. And C squared is A squared plus B squared minus 2BC cosine C. Note that you can rewrite the law of cosines, for instance. If we look at the first equation and solve for cosine A, we can write that cosine A, if you do the algebra, you'll find that it's B squared plus C squared minus A squared divided by 2BC. And similarly, you can solve for cosine B and cosine C. So keep that in mind when you're solving problems. First example, find the angles of the triangle with side length A equals 6, B equals 8, and C equals 12. So we apply the law of cosines. Cosine A is B squared plus C squared minus A squared divided by 2BC. B squared is 8 squared minus plus C squared, which is 12 squared, minus 6 squared divided by 2 times 8 times 12. Using a calculator, that's equal to 0.89583. Apply cosine inverse on both sides and make sure the calculator is set in degrees. We get that A is cosine inverse of 0.89583, which is 26.38 degrees. To solve for angle B, first we apply the law of cosines. Cosine B is A squared plus C squared minus B squared divided by 2AC, and that is 6 squared plus 12 squared minus 8 squared divided by 2 times 6 times 12, and that's equal to 0.80555. So B is cosine inverse of 0.80555, which is 36.34 degrees. Now we can find angle C by applying the law of the law of cosines again. But there is a faster way to do this, namely using that the sum of angles in a triangle is 180 degrees. So C would be 180 minus 26.38 degrees minus 36.34 degrees, which is 117.28 degrees. Second example, given that angle A is 80 degrees, B is 16, and C is 12, let us solve for the triangle. We start out by writing A squared is B squared plus C squared minus 2BC cosine A. So A is 16 squared plus 12 squared minus 2 times 16 times 12 times cosine of 80 degrees. And that's equal to 333.32. To find A, simply take the square root of 333.32 to get 18.26. It remains to figure out angle B and angle C. To find angle B, apply the law of cosines again. We have cosine B is a squared plus c squared minus b squared over 2ac. So 18.26 squared plus 12 squared minus 16 squared divided by 2 times 18.26 times 12. And that's equal to 0.505266, which means that B is cosine inverse of 0.505266, and that's equal to 59.65 degrees. Finally, angle C is 180 degrees minus 59.65 degrees minus angle A, which is 80 degrees, and that's equal to 40.35 degrees. Next, let's look at a word problem. A ship travels 40 miles due east and then changes direction as shown in the figure below. After 30 miles in the new direction, the ship is 56 miles from its point of departure. Find the bearing from point B to point C. Now, to find the bearing from point B to point C, you're going to start at B, draw the north line, and take the clockwise rotation to side BC. As you can see, it's illustrated in blue on the figure. So we start out solving this problem by applying the law of cosines to figure out angle B. So cosine B is a squared plus c squared minus b squared over 2ac. That is 30 squared plus 40 squared minus 56 squared divided by 2 times 30 times 40. And that's equal to minus 0.265. And that means that B is cosine inverse of minus 0.265, which is 105.37 degrees. So all of angle B is 105.37. If we take away 90 degrees from that, we get exactly the bearing from B to C. So the bearing from B to C is equal to 105.37 degrees minus 90 degrees, and that's equal to 15.37 degrees. Finally, let's look at a problem where we have to compute the area of a triangle given the length of the three sides. Find the area of a triangle with side length A equals 5 centimeters, B equals 9 centimeters, and C equals 8 centimeters. Since we're given all of the length of all of the three sides, we can apply Heron's formula to figure out the area. Recall that Heron's formula for computing the area of a triangle is A equals S minus A, S minus B, S minus C, all under the square root, where S is the semi-perimeter of the triangle given by A plus B plus C over 2. So in this case, our semi-perimeter is 5 plus 9 plus 8 divided by 2. This is 22 divided by 2, which is 11 centimeters. So the area is the square root of 11 times 11 minus 5, that's S minus A, 11 minus 9, that's S minus B, 11 minus 8, that's S minus C. So that's square root 11 times 6 times 2 times 3, which gives 6 times square root of 11, and that's roughly 19.9 square centimeters. That is the area of the given triangle.